This is our Unit 9 in our Qualitative Research Methods course. I am Dr. Anita Black, your professor for this course. And this week we get into the juicy stuff. We're going to talk in this unit and next unit, the data analysis basics. We're looking at a phonetic iterative approach. Here is the overview of what we will be discussing in this unit. We're going to start off with the phonetic iterative analysis. Then we'll talk about organizing and preparing data, talk about coding. We're going to then move to a discussion on analysis logistics, including primary cycle coding, looking at focusing the analysis. We're going to also discuss secondary cycle coding and end with synthesizing activities. So here once again we see the phonetic iterative approach, with which if you leave this class with nothing else, you should know what the phonetic iterative approach is. As the book discusses, many qualitative researchers claim to use a version of the grounded theory as part of their data analysis procedures. And grounded theory involves studying data as the data emerges in the field. In other words, the study's emphasis will develop from the data that's collected rather than from predetermined research questions. The problem-based phonetic approach of this book uses an iterative approach. An iterative approach asks the researcher to move back and forth between emerging data in the field and relevant theoretical literature. This unit uses this phonetic iterative approach to explain how to organize data and the key aspects of a phonetic iterative data analysis process. So let's go over this concept one more time. Iteration is a reflexive process where the researcher visits and revisits the data, connects empirical materials to emerging insights, and progressively refines the focus and understandings. It asks, what are the data telling me? What is it I want to know? And then it brings those both together and looks at what is the dialectical relationship between the two. You know, just like reading a cookbook, it doesn't mean you've cooked anything. You can spend days reading about data analysis without really jumping in and doing any analyzing. You don't need a perfect plan in order to start. Well, some people might actually protect that, but this is based on their own experiences, their own preferences. So look at figure 9.1, and this shows the funnel method that's associated with the phonetic iterative approach. Let's move on now to organizing and preparing data. To get more focused data analysis, researchers need to systematically organize their data. All their raw materials in this process can be exciting and a little bit overwhelming if you've collected a lot of data. Researchers should reflect on ways that they personally best process data. So the book presents a few different ways of organizing and preparing the data, but really Tracy's big takeaway is that you need to find the way that works best for you. The book presents a few different ways to organize your data based on chronology, by source, by type of data, by the attributes of participants. And these different organizational schemes have advantages and disadvantages. The front logical schemes organize data based on the data collection, and the advantages include showing the trajectory of data collection over time and easing analysis really focused on correlation or causation. Another option is to organize via the type of data. For example, placing all field notes together. Data can also be organized by source, by linking all the data together from the same participant. For example, a family organizing via attributes links data by specific demographic characteristics such as age, gender, or race. Again, remember, there's no perfect way to organize, but the way data is organized will impact the analysis organization. It can be really tedious, but it's extremely important, and and it's intellectually not too taxing. As again, it's what you as a researcher want to do. What's best way for you to organize? So we've looked at our data, we've organized our data, and now we're going to get into the coding. And let me tell you, it's not as bad as it sounds. I did my coding a couple times, especially when I did my dissertation. That was a meta-analysis. So what is coding and how do we start? Tracy tells us that 3/4 of the way through data collection, researchers should read and reread the data during a data immersion phase. Now, during this time, or this phase, researchers can talk to other individuals about emerging interpretations of the data. You need to immerse in the data, jot down some hunches and ideas, but reserve judgment. Ask questions such as, what's going on here, and what strikes you about the data? After you've immersed yourself in the data, it's time to begin the coding. Coding simply refers to labeling and systemizing the data. And as I was saying, in a note that you may or may not have in your version of the book, Tracy says that she likes to think about data as a huge buffet of all kinds of different dishes. The coding process then distills this buffet into main ingredients, and the researcher can create an original dish from these ingredients, one that will complement and add something new to the research buffet. So as the book notes, coding is accomplished via a variety of methods, including coloring, cutting, or even through the aid of computer software. For a very good guide on coding, check out 9.1 that's on page 215. It includes motivating questions and coding domains, and I put a big star on my reading about this. This is a very good guide that's very detailed. So I would definitely check this out if I were you. And here are some of those questions for coding that come right out of that. So what is happening here? What strikes me? What are people doing? What are they saying? What are they assuming? How is the same or different from other scenes? What has surprised or intrigued me? What disturbed me? In what ways does the context motivate certain behaviors or beliefs? And who or what is winning? Who or what is losing? Okay, so let's move on to different approaches to coding, or what we call the logistics of analysis. We have some manual approaches and some computer-aided approaches. The manual approaches begin by printing a hard copy of the data. As a piece of advice, researchers probably want to use a wide margin and mark up the data with highlights and markers. Next, researchers might cut and pile their data. You can hole punch, and then you can string together relevant codes together. So you see here a picture of a coding effort, whereby different piles have been created and different post-it notes have been used to organize the data. And of course, you see the little dog, which is clearly the most important thing in this picture. Whatever works for you. Again, that's Tracy's big piece of advice from this chapter, is figure out the way that you can organize your data that works for you, that makes sense for you. So the discussion of manual approaches begins on page 216, and please see the Researcher's Notepad 9.1, which is manual coding visual displays, on page 217. So let's move on to computer-aided approaches. You can do computer-aided coding with just everyday software. So we're talking about Microsoft Word or Excel. These types of word processing and spreadsheet apps have made data analysis much more efficient than some of these older manual approaches. So for example, Excel can be used to store and categorize. For more advanced computer analysis, Tracy recommends and discusses computer-aided qualitative data analysis software later on in chapter 10. Let's talk about the primary cycle coding. Begins by reading the data, assigning words that capture the essence of the data. So for instance, writing in the margin manually, adding notes, adding observations, or you can use a Word document where you are putting your data within the Word document, as well as adding notes and observations. Next, we look at the first level codes. Now, these are descriptive codes, and they really require little interpretation. These are the kind of codes that a research assistant would be able to use, would be able to understand. Now, looking at primary cycle coding, this also involves, and primary cycle coding also involves identifying in vivo codes. In vivo codes use language and terms that the participant uses themselves. So think of these as slang terms used by the participant that the research gives meaning to so that others can understand what those words mean. In the primary cycle coding and throughout, researchers use the constant comparative method to compare data applicable to each code and then modified the codes based on new data. So at the bottom of page 220, Tracy asked the question of how detailed should you be during these primary cycles of coding? And then she discusses both lumping and fracturing. So lumping is exactly what it sounds like. It's taking the data and putting it into a larger category. So that would be less specific, whereas fracturing or splitting takes the data and divides it into smaller slices. If in doubt, Tracy encourages researchers to use more detailed fracturing first and lumping second. Let's talk now about focusing the analysis and creating a code book. It's helpful to create a list of codes. As you are coding, you may become more focused. So this list can be transformed into a code book. Code books serve as a legend or a key for your data, as they can change and transform throughout the analysis process. Code books also help explain analysis to advisor committees and external review boards. For an example of a code book, see the researcher's notepad 9.2 that's on page 222. Now, the number of codes in a code book varies from person to person and project to project, but Tracy recommends that we should limit our codes to around 25. Also, the more people involved with the coding, the more detailed the code book should be. As you're doing your coding and as you're creating your code book, remember to revisit your research questions and synthesizing concepts and other ideas throughout the analysis process. So research questions should be reworked after the primary cycle coding. For a quick list of the considerations, check out and consider 9.2 that's on page 224 for some ideas on how to focus data analysis. So we've talked about primary cycle coding, so let's move on now to secondary cycle coding. During secondary cycle coding, the researcher examines the codes that are created during the primary cycle coding and begins to synthesize and organize them into interpretive concepts. So secondary cycle coding uses second level or analytical codes that are also called focused codes. Second level codes draw from disciplinary concepts. It's important to use the most relevant and related disciplinary concepts that are related to your data. So you take these disciplinary concepts from your reading, from your literature review, and so the second level codes can be created through a perspective conjecture. The perspective conjecture considers novel juxtapositions and borrows concepts from other theories. Unlike primary cycle coding, the second level coding can only be completed by an expert, someone that's well versed in the literature, and it usually cannot be delegated to a research assistant who is unaware of the overall theories that are connected to the project. In secondary cycle coding, researchers also identified groups and patterns within the data through axial and hierarchical coding. This type of coding involves reassembling data that was fractured during the primary cycle coding process. Hierarchical coding specifically includes grouping together various codes into hierarchies or umbrella categories. So if you look at exercise 9.1, it's on page 227. This exercise is titled Grouping Together Codes via Axial and Hierarchical Coding. So one thing that comes out of secondary cycle coding is that we may discover that there is more data that needs to be collected. If this occurs, researchers should go back into the field and collect more data that's related to the specific issue that's been identified. This is called theoretical sampling. New data collected does not yield new insights, and researchers have researched theoretical saturation. It's a concept that we discussed in previous chapters, but again, the idea is that going back into the field, that we're not gaining any new knowledge. So in a sense, we have a diminished return on the investment into our research, and that has the saturation point. And finally, we've talked about primary cycle coding, secondary cycle coding. So let's now finish up with looking at synthesizing activities. It's important to record your emerging analysis ideas and thoughts throughout the coding process. Create a document that describes all of your analysis activities, so you're almost writing a story about what you were doing in the coding process. Now, this will help you when you write the methods section later in your final paper. Make a point to write analytic memos as part of the analysis process. And as an analysis outcome, this analytic memos are a longer version of the analytics asides that are described in Chapter 6. Inner-focused on the meaning of codes and the connection between the codes. So again, analytic memos define the code. As we've said, you're not doing the project that you're proposing. You're not going out and collecting data, but you still need to be able to describe in your methods how you're going to do your coding, how you're going to synthesize your activities. So explicate its properties that provide examples from the data to specify the conditions under which it arises, maintains, or changes. It describes its consequence, shows how it relates to other codes, and then develop a hypothesis about the code. So researchers should also play devil's advocate with themselves through what's called negative case analysis. This process asks the researcher to seek out data that does not align with emerging analysis midway through the focus coding. So researchers can also create a loose analysis outline. The loose analysis outline notes primary research questions and how codes are attending to those questions. So if we run an example from Tracy's own research, look at page 230 under the researcher's notepad 9.4 for an example of loose analysis outline. This unit includes the rules on analysis, but Tracy also tells us that these rules are not written in stone. Tracy encourages us to play and try different analysis techniques. In fact, she tells us to push ourselves to at least try the practices that seem hard or unfamiliar to us. So, in summary, what we've talked about in this unit, we reviewed the nuts and bolts of frenetic qualitative data analysis, including data immersion, coding, and an analysis. So as a good review of what's been said in this unit, you can look at the exercise 9.2 on page 233, which is the iterative analysis basics. And it basically uses one box to sum up all that we have talked about in the unit. As usual, if you have any questions, please post them under the office hours. And that's all. So let's move on to computer-aided approaches. You can do computer-aided coding with just everyday software. So we're talking about Microsoft Word.